So, ok, am pornit. Bun, deci, bună seara tuturor! Ne revedem după o pauză destul de mare în ceea ce privește webinarele cu care ne-am obișnuit. Prima veste pe care am să o dau este că acesta este primul webinar sub egida noi asociații, care se numește Asociația Specialiștilor în Managementul Pierderilor de apă. Aceasta este marea veste din această seară, o asociație nou înființată de profesioniști în acest domeniu. Vom reveni cu detalii cât de curând. Webinarul din această seară ne aduce doi prieteni vechi, pe Steve Cavanaugh și Drew Blackwell de la Cavanaugh Solutions. Ei au mai fost la noi cumva acum un an sau 2 ani. Iar subiectul de astăzi este destul de important și chiar critic, referitor la modalitatea de a audita datele de intrare necesare pentru balanța de apă și cel mai probabil a indicatorilor de performanță. Ceea ce veți vedea în această seară este o avantpremieră a unui atelier de lucru care va avea loc în data de 7 octombrie la Universitatea Tehnică de Construcții București. De asemenea, vom reveni foarte, foarte curând cu detalii și pentru acest lucru. Pentru participanți, o să vă rog ca pe parcursul acestui webinar să închideți microfoanele. Orice întrebări vor fi puse în chat, iar la final eu voi citi și voi traduce, dacă este cazul, în limba engleză aceste întrebări, astfel încât pe final să apară foarte bine pe canalul nostru de YouTube. So, after saying this, Drew, Steve, thank you very much for coming here. Okay, if you didn't understand anything, don't worry, but I know you understand some Romanian. Okay, so at this moment, I will let you do the webinar. I just lay down all the rules. So the screen is yours, so to speak.
Perfect. Mulțumesc, Alex, and bună seara. Mă numesc Steve Cavanaugh, and puțin romanesque, so that's about it. It's finished at this point. So thank you for being here, and we're excited to be a part of this first webcast. So Drew's going to manage the slides, and we'll move through those. And we had conversation with Alex of putting some questions in the chat. And then Alex will also sort of interrupt with some questions to help get some clarification on some things as we go. So advance, if you could, Drew, we'll talk about the agenda very quickly. And part of this gets into the introductions, and I'll do that now. I'll introduce myself a little more fully, and then I'll ask Drew to do the same. And this is the layout of the actual webcast today. Water balance, system audit boundary, data reliability, a little bit about the preview, and then a little Q&A. So very quickly on my background, in the water loss profession, I'm a licensed professional engineer, but in the water loss profession, it actually started in 1997 in Romania. Our history starts in leakage management in Romania, working at the time with Rajakiash, now APEI Vital. So some great learning both ways between technology and correlation and data loggers, but very active primarily in the United States, working with major water utilities, helping them develop their non-revenue water programs. So I'll talk a little bit more about that as we go along. But also I share a role as the chair of the Leakage Emissions Initiative for the International Water Association, which Alex and Alan and several of you are also active in as well. And so thank you for your attendance and contribution at those conferences and in those specialist group working groups. So Drew, if you could do a brief introduction of yourself, and then I'll sort of go through objectives and the introduction.
Thanks, Steve. I'd be happy to. Good evening, everyone. My name is Drew Blackwell. I'm the Director of Water Efficiency with Cavanaugh. Alex, thank you very much again for the invitation to speak with this group and share with the association. I've been with Cavanaugh for about 8 years and in charge of our water efficiency service line. We work with water utilities to help them design and progress their NRW management programs. We also administer statewide large-scale training and technical assistance programs to introduce the water balance, some of the key concepts that we're going to look at today, and also help them equip utilities to formulate a water loss control program and instill best practices in their water utility. So happy to introduce a lot of concepts today and look forward to sharing them in more detail in person in Romania.
Great. Next slide, Drew. So objectives in this discussion today is the water balance, and many of you have seen that, but we'll maybe get a little question and answer about that in just a bit. To talk about communication of your non-revenue water in terms of the volume and the value, and then also how valid our data is. We're going to talk through water audit validation, and then we'll talk more about the one-day workshop. Okay, Drew? So really on sort of the big picture, and this is important as we think about a non-revenue water program, in many cases, water utilities globally are counting and looking at their water in terms of a percentage unaccounted for or a percent of system input volume that's lost through leakage. And in many cases, that becomes a metric by which they're seeing how they're doing, a measure of performance, if you will. But the challenge is that we have a lot of steps, and it's not just taking how much was supplied into distribution system minus how much we bill and then calculating that percentage. There are many steps that we have to work through to understand and quantify what actions we should take. And so we've sort of laid out the what we think are the effective steps of a non-revenue water program, including performing an annual water balance, a water audit, we'll call it, back and forth a few times, to break down real and apparent losses, also known as commercial losses, or those that have value at what the water can be sold for. And then starting to uncover errors within the recording and the accounting of that information through a level 1 validation so that we get to an accurate baseline. From that accurate baseline, we then go deeper and we dig into those commercial losses. We look at theft, metering inaccuracies, errors in the billing. So that's what we call a technical analysis. And we do the same thing on leakage. And it's two very distinct ways that we break out and look at commercial losses and the leakage. That's done through a real loss component analysis to say how much of that's coming to the surface that we're already interacting with, how much of it is background leakage based on our system physics, and then how much of it is that unreported leakage that we can interact with. We went and deployed technology, data loggers, equipment, et cetera. Third stage really looks at the economics. And in many cases, if you're lining up for funding, you have to show that you are operating at your economic level of leakage, your economic levels of non-revenue water, that we're not spending too much trying to recover losses, or we're spending too little. And so understanding by each component, what is the cost of our loss in terms of real money, and what's the cost of interaction or intervention. That then can help to appropriately inform a program of intervention. And many of you have been already putting these programs in place. And I realize that as we bring some of this information, but the program and the stages that we've got should be able to support why you're doing setting up DMAs, why you're doing active leak detection, why you're doing meter replacement. Unfortunately, at least in the States, a lot of utilities go from, we think we've got this much percent loss, and we jump to the intervention. And it sort of is a back and forth. So very quickly, just populate it all the way through if you could, Drew. This chart is sort of an example of how we fall into that trap when we look at loss as a percent of system input volume. You can sort of see there of how much is in supply in the blue bars, how much we are billing in sort of the green graph. And then a traditional way of looking at it is taking the difference. And then to get to that percentage, which is on the right side, simply dividing the water loss by that system input volume. In many cases, there's action that's being taken based on that percentage when really the water loss has never changed. But what we see when we're looking at it as consumption and supply go down is basically skewing that percentage. Unfortunately, many utilities move straight to the intervention, again, based on that percentage evaluation. So what we're trying to bring in the form of this webcast, the workshop, or some of the tools to be able to defensively describe what we are doing on leakage management, on commercial loss management, why, and the value of it, interacting with it. Go ahead, Drew. Next slide. All right, so Drew's going to take us through the water balance, but a quick pause there, if we could, either for Alex or anyone that's on the line that has a quick question on sort of that overview programmatically. Okay, carrying on, go ahead, Drew.
Great, thank you, Steve. So I'd like to walk through the water balance with everyone. I think for many on the line, this may be a little bit of a refresher, but a good refresher nonetheless. We understand that every system has leakage, has losses, and to what Steve mentioned earlier, establishing a baseline of water auditing data is really what we see as the first step of effective NRW management in a utility. And so the methodology that we'll be talking about really helps to set a path to building your water loss program or NRW management program. So this water balance that we're showing from the International Water Association and the American Water Works Association represents a mass balance, starting with the treated metered sources going into the drinking water distribution system. So moving left to right, this mass balance will have each of the columns in the water balance totaling the same volume, thus balancing. So through this process, we are systematically accounting for all volumes of water going into the distribution system. We're doing that either through measured metering or some form of estimation in our system. So starting over here, just a simple definition of the water balance. It is really the summary of key water audit data from the source to the customer with the sum of those quantities in all columns balancing. So I'd like to walk through just these different components. Again, we want to just introduce this, but go into each of these components in more detail later on in the in-person workshop. But starting on the left-hand side of the screen, we're looking at really different components of our water supply profile. Our own sources could be water that we are through surface water or groundwater wells that we are treating at a treatment facility. And then any water imported, maybe water that you treated sources that you are purchasing from another utility or another agency. And then if you're exporting any water, delivering water to another community or another water utility, that would be known as water exported. And each of these, a utility may have one or all of these as part of their water supply makeup. But this is a very important part of our understanding our water audit and calculating our water losses. Steve will talk in a little bit more detail about each of these in a moment. But moving from water supplied, moving now to the authorized consumption in the green section here. Our authorized consumption is made up of, it's either billed or unbilled or metered or unmetered. Those are the four different ways we want to break down the authorized consumption in our system. Billed metered consumption, that's usually the largest component of our authorized consumption. That's our metered customers, residential and commercial. We may have some customers that are billed but not metered. And then we may have just some facility use where we're metering the consumption, but we're not billing for it. There's some exemption for billing. And then, of course, there may be some operational use, such as flushing or fire suppression, where there is we are not metering the consumption or billing for it, but it's still an authorized use that we must account for in our authorized consumption. The difference between our water supplied and the authorized consumption will give us our water losses. But as many of you know, we don't want to just have a single volume of water loss. And as Steve shared with us just a moment ago, we don't want to just look at our water loss as a percentage of the supply input volume. Rather, we'd like to break those water losses down into apparent losses, which is the water making it to the customer, but we are not measuring it accurately or capturing the revenue for that. Or we want to break it down into real losses or the physical leaks in our distribution system. Each of those losses have different subcomponents. Apparent losses have 3 subcomponents: data handling errors, customer metering inaccuracies, which is typically the largest component of apparent losses, and then any unauthorized consumption in our system. And again, the real losses are the physical leaks within our system that could occur on leaks, main breaks, service line breaks, and also leakage at overflows and storage reservoirs. Then finally, in the yellow that part of the water balance that we see here, making up what we know as our non-revenue water. And instead of looking at our non-revenue water as a percentage, we want to also encourage you to consider looking at it in terms of the volume of non-revenue water that we're losing each year, how much that's costing the utility annually, and then how reliable is the data that's giving us this information in the first place. So again, just a very quick overview of the water balance. For many of you, I know that was a refresher. For those that this is a new concept for, it is really the foundation of quantifying our non-revenue water in our system. I mentioned looking at it rather than our non-revenue water as a percentage of our supply input, but instead looking at it in terms of volume, the values and validity in of our non-revenue water summary. So taking the non-revenue water components and breaking it down in each one of these different lenses to examine what our non-revenue water looks like in our system. Let's see, just want to take a quick check on questions. Alex, do we have a question come through?
Yes, Joe. If you could go back to a little bit the slide with the water balance, I just asked the question very shortly in Romanian. Întrebarea pe care o să o pun se referă la faptul că balanța apei de aici este foarte detaliată, inclusiv la nivel de subcomponente. Și întrebarea, dacă în situațiile în care datele pe care le ai dispoziție sunt aproape inexistente, în ce măsură poți calcula și acele subcomponente și dacă le poți calcula, care este marja de eroare, adică te poți încrede în rezultatele respective. Mă refer aici în special la subcomponentele pentru pierderea. So the idea is, for example, in situation when you have data with low confidence or in existing data, like you have problems for the system input volume or even for the built water exported, how can you manage to calculate to a certain degree of accuracy the subcomponents? Or maybe this is another question. If you manage to do this, how can this volume of the subcomponents can be of use to you when you have so many unknowns?
Great. That's an excellent question, Alex. Thank you. So if we don't have, so the reliability of our results from our calculating our non-revenue water is really based on, can be heavily based on the data that we have available. So if we have to estimate some of these volumes in the absence of data, we would reflect that in a sense of our data reliability. There is a criteria that we would look at the practices and policies in your utility surrounding each of these components of the water balance. Perhaps let me give one example. With our water supplied, if we have 3 meters that we're registering the flow of treated sources going into the distribution system. If we have never tested done a volumetric test on any of those meters, then we have a low sense of reliability. If we are testing those meters annually or at regular intervals, we have a much higher sense of reliability. So in the first example, if we're not testing them, then that automatically gives the utility something to consider to improve their data reliability in their system. The same if we have just an estimate of consumption data, for example. One recommendation might be to improve the method of estimation or take some metered consumption volumes and extrapolate that to better inform the water audit.
Alex, I'll add one comment. This is a very important question that you bring up, because often there's pressure on the utilities. Go fix the leaks, go solve this percentage issue. And in many cases, that's why I showed the programmatic steps of improving the reliability of the data. Sometimes it's too soon. It's too soon to interact. And there's a false sense of, well, if I just do this, it's going to solve the problem. But because the estimates were so grossly out of skew, early on, there's a missed expectation. What this does is it gives the utility the defensible means by which they are improving that baseline and then now interacting with it. So it's a fundamental question. I appreciate you raising it. Okay, go ahead, Drew.
Great, thank you. Where we left off, again, rather than looking at our non-revenue water as a percentage, we are encouraging to also look at it in terms of the volume of water loss, the cost of the non-revenue water components on an annual basis, and then the validity or reliability of the data. These next 2 slides come from the industry standard tool that is being used currently in North America, the American Waterworks Association free water audit software. This is different states across the United States are either requiring use of this industry standard tool or are incentivizing the use for their utilities. And much of the data validation and data reliability pieces that we're going to be speaking to have been through many years of practice using this industry standard tool. It also gives a summary, a non-revenue water components summary. Apologies for some of the imperial units here, but have also shown this in megaliters and cubic meters for context. But the main focus here is to look at our different non-revenue water components, both from a volumetric standpoint and a cost perspective. All right, I will pause for any additional questions before handing it back to Steve, who's going to talk a little bit about our water audit system boundary, where the water is coming into our distribution system and where it's leaving it, and why that boundary is important. Alex, do we have any questions from the group, or any that we'd like to prompt the group with? Yes.
Not at the moment. However, I have a question. Probably is the question you have been expected with this graph in front of you. That is that when you are looking at non-revenue components in volumes, you have a certain view of the situation, but it will change when you are looking from a commercial perspective, when you are looking for the cost. So I see that red component over there about customer metering inaccuracy, and I wonder if you want to have a little comment about that.
Sure. So the customer metering inaccuracies, again, this is usually the largest component, subcomponent of the apparent losses. And to quantify that volumetrically, we would need to have some customer meter test data. The reality, Alex, at least in the United States, many utilities that we work with do not have a lot of customer meter test data. If they do, the priority is on the larger commercial meters that they're testing. But to quantify it, the preference is to have some customer meter test data. In the absence of that, of having any customer meter test data, we can estimate, make some inferred estimations on how our entire customer meter population is performing. From a cost perspective, we are calculating the cost of our metering inaccuracies at the retail rate that the water is sold. And so it's not, if there are any base rates, for example, those would be excluded, but we want to value that at the water rate that is sold. Let me just, in contrast, the real losses or the leakage that you see here in blue is by far the largest component, volumetrically and a cost perspective. The real losses, again, if I just going to go back to our water balance, the real losses down at the bottom center column is really just quantified through a process of elimination. Once we understand our billed authorized consumption and unbilled authorized consumption and apparent losses, what's left over is are the leaks in our system. And the way we would value the leakage in our system would be the cost to produce another unit of water, cost for chemicals for treatment, cost for power for pumping and distribution in our water system.
And I think as well, it's a little different in the States, but I think in Romania, there's also an abstraction cost as well. So that's the cost of additional volume of water. So that typically plays in to that cost, because that would be variable if you had, as Drew said, to produce that next unit of water. Any other follow-up there, Alex, before we move on to the boundary?
Well, it's not at the moment, so I propose we move on.
Okay. All right. I'm going to take just a couple minutes and talk through the importance of the water audit system boundary, and certainly for the water utilities that we work with, this is one of the the major things that we find as errors, challenges of how they develop that boundary. So if you could, Drew, next slide. So again, back to our water balance, we're trying to get first an understanding of the total system input volume of what's going into the system. And that can be broken down with several different categories. So in the water supply, next slide, Drew. Kind of the water supplied, again, it's the volume from your own sources. This could be well filled. This could be pulling from the river. And then if you are adjacent and have connectivity to another utility system, then there also could be water that is imported into the system. Obviously, you've got the ability for water to be exported to another system. That would be water exported. So the water that you supply from your own sources, what you bring in from someone else, also minus what you're exporting, kind of gets you that total. So the water imported, where are we purchasing it from? What kind of agreements are there? What type of meters are there? Are those meters being evaluated? And then how is it being tracked? Go ahead. So looking at on the water export, very similar. Is it a bulk sale? What type of meters are there, and how are you tracking that relative to the water that is exported from the distribution system? Go ahead. One of the other main areas that we see of challenges of getting to an accurate volume supplied is not adjusting based on metering and accuracy. And when we say how accurate are the meters, in many cases, utilities globally, I know if they're doing testing, they may be doing only electronic signal calibration, the 4 to 20 milliamp transfer of the signal of what the meter is measuring, rotations, etc., and then translating that to actual cubic meters. So in many cases, the utilities are doing that. What they're not doing is a secondary volumetric test of taking a known quantity of water and moving that through the distribution system and evaluating that in comparison to what the meter is actually reporting. So that's an important piece to get adjusted as well. All right, let's go to the next slide, Drew. So this section is on boundary and the importance of boundary. And this graphic shows in many cases the complexities that water utilities across the world have. And what we're really doing of defining this boundary is what is going into our distribution system. And so it could be from a well field that's there, of those SC meters, the well meters. It could be from a couple of different treatment plants, from a raw water meter treatment plant, a finished water meter. It could be an intertie from another utility. And there could be also some exports out. It could be into refilling a reservoir, an intertie, or storage. And so you can see just from this graphic that it can be very confusing of which meter to use. And in most cases, water utilities get one number. How much water did we produce last year? And then somebody in that department is maybe tabulating and getting that number. And it can be challenging because meters could be missed. It could be the wrong meters. So this is the importance of the boundary. Go next slide, Drew. I'm going to give a couple of examples very quickly and just to sort of pause and let you think about which meters we would use in calculating the actual water that's going into distribution system. So just looking at the screen there, the question is, which meters will we use going in? All right, go ahead and advance. So in this case, obviously we would want to use M3 to determine the volume from our own sources. M4 is a meter that is water that's coming into distribution. And then M5 being a meter that is exporting the export water that's there. Let's go to one more example, Drew. So a little bit more complex here. In this case, which meters would we use to describe the volume into our distribution, or the volume supplied into distribution? Because this is an important piece to determine where the audit is. All right, go ahead, Drew. So in this case, we don't have a meter coming off of treatment plant B, so we would need to utilize the input meter, realizing that there are losses or inefficiencies within treatment plant B. But that, back to Alex's earlier question, that's the best we have right now as we're trying to put together this water balance. So we would use M3, M4, and M6. Let's go to one more, Drew. So this last one is actually Flagstaff, Arizona, a very complex system, if you see in here. And it's really determining, you know, which meters are supplying into distribution. And the reason we show this is there's a lot of complexity, but it's getting it down to where is our last point that we can measure or accurately estimate of the water that's going into distribution. And you can see those in red there. In many cases, again, globally, I would submit this is one of the number one challenges that we see is water is not properly tracked because they've used the wrong meters or the wrong estimating points. Okay, Drew, let's keep moving. And let's move us, I think, now into our session on data reliability. A quick pause for questions. I saw one come into the chat. Alex, if you can bring that question forward.
Well, was not a question. Someone had an urgent business to
Okay.
leave. But however, I have several questions.
Please.
I see that okay, first question. What do you do in the situation when you have virtually nothing? No, not a single meter. Or for example, you have a big supply system with lots of networks and you only know what entering. How much effort you have to put into it in order to have, let's say, accurate figures for each individual network. Or maybe first step that you should do is to install flow meter and then reassess everything. And maybe the last question, based on your experience in United States and Romania, what are the differences between the two countries in respect of this establishing the water balance, and what are the similarities, if you can put that in a few words? Thank you.
Sure, great questions. I'll kind of hit a little bit on both, and maybe Drew, you add to. So the first one is it's not uncommon for, Drew gave a great example, some wells to be metered and a well meter is out, as an example. So there may be 3 that are metered and 3 are out. Well, you have to use what I would call informed estimates, judgment, testing, ways that you're able to make some approximations. But that's how it's done. I mean, it starts out with informed estimates and it has a very, very low reliability. So you would also caveat the results very, very appropriately to say, the first thing we need to do is we need to start really making headway, not of, in some cases, you've got obvious things of leaks that are closing streets and things like this, but there needs to be an effort on getting meters in addition to fixing those leaks that are surfacing. But we need to get meters or better estimating means in place. And so this process gives that catalyst to let that be a priority to get those meters in. Now, the other piece that you asked, and it's been a bit dated, but I've observed certainly APEI and some of the things that they have been doing, and they've been very diligent on sub-metering and trying to improve the estimates. It's been a while since I've done a detailed dive, but I would imagine that it's on par for what we see in U.S. cities. They are getting their hands around. They're trying to implement more improved metering and estimating methods. So I think needs to be a continuous effort to improve the metering and elements there. That's what I would offer. I'm sure that this group, and certainly in our workshop, we can have a much more robust conversation about it. But anyway, let me stop there. Drew, anything to add before we move on to reliability?
I think you hit most of it, Steve. And in the United States, we have the majority of utilities that we work with have supply metering and customer metering. However, there are some that don't have any that have no customer metering, and in those cases, sometimes those customers are billed, sometimes they're not billed, and sometimes it's a combination. I would say the priority when it comes to metering, we want to have as best available data for the supply input volume as possible. Then if we're left with the consumption data, our estimation methods, improving those estimation methods until we can have some metered consumption volumes to base our non-revenue water calculations on, is the general recommendation.
Okay, go ahead, Drew. Let's take us through data reliability so we can get to a couple questions at the end.
Okay, sounds good. All right, so I gave an example earlier with supply meters, the treated water that is entering the distribution system. And I gave an example of a utility that has never volumetrically tested those meters versus a utility that is testing them frequently or on a regular basis. And in the first scenario, we have a very low sense of reliability in those numbers. In the second, we have a much higher sense of reliability of the supply volume going into our distribution system. So I want to give just a little bit of historical context in the United States, where this methodology of data reliability with our non-revenue water has originated from. Back in about 2014, there were thousands of water audits in the United States. And so there was a research project done to better understand how realistic are the results from all of these water audits that the utilities are using. And the results showed that many of the water audits had a high percentage of unrealistic results. And those sources of uncertainty came anywhere from a poor quality of data in supply metering, or just a misuse or misalignment of the methodology. So from those results prompted the need for some form of standardization to validate the data that is being input into determining our non-revenue water and our water losses. So here what we see on the screen are 4 different states and a regional entity in the United States. So California, Delaware River Basin, Georgia, Tennessee, and Texas. And so they looked at the total number of audits and understood the number of unrealistic audits that we saw. And then again, those sources of uncertainty are shown there. Zooming in just a little bit, in the state of California, they gathered water audit data from 2016. And apologies for the imperial units here, but I do have one that we brought into SI for some context. But the main takeaway is that through this data set of over 400 water utilities in the state of California, there were some significantly unrealistic results that were being observed. Certainly, any negative numbers for our apparent losses and real losses is going to be an unrealistic result. And we were also seeing very extreme outliers in cost data as well. So one, just for context and bring it into to leakage service connection per day, have that shown here in liters per service connection per day as well. But again, those negative losses are certainly a place where those unrealistic results are occurring. All right. So from this, again, the need was seen for having some type of standardization to validate the water audit data. Right. Basically understanding that any uncertainty that we have in our water supply data and our authorized consumption will translate into some form of uncertainty when we're looking at our non-revenue water components. Those sources of error, again, instrumentation, database management, just human error is introduced, and absence of information that we've already been talking a little bit about. So there is an organization, the Water Research Foundation in the United States, that took the initiative to produce a manual to standardize the water audit validation, so all utilities can be on the same page of how to assess how reliable their data is when they're estimating their water losses. The two main objectives for validating water audit data is first to make sure that the water balance methodology is applied correctly, that the right volumes are going into the right inputs to calculate our non-revenue water. And the second objective is an assessment of the practices and policies that the utility has in place for each input. Similar to the supply meter testing example that we gave. What types of testing are they doing on the meters? How often are they doing it? And there is a certain set of criteria of those practices and policies for every component in the water balance. There are additional levels of validation, but the one that we're focusing on here is just a high summary level of data to ensure so utilities can understand their sense of reliability. Through the Water Research Foundation project, a sample of over 700 water audits were collected to look at what were the results from the self-reported water audits versus after they have been validated now through this new standardized approach. And we saw in large part, most of those components, the reliability from what the utilities thought they had was not as much as they actually did have after going through that process. But it still gave them, the utilities, a step-by-step approach on how to improve the reliability in their data. Now, looking at the overall data validity of these results, on the top graph shows a distribution of self-reported water audits. And then after those water audits and the utilities have gone through the standardized validation process, the distribution becomes much more tighter. The utilities understand the criteria and how to better assess the certainty or uncertainty of the data going into their water audit. And then finally, there's a lot of text here. I'll just summarize it verbally. There are some things that this standardized approach does, and there are some things that it does not do. Some things that it will do is understand or evaluate high summary level data supply data, consumption data, system data, and cost data, and assess the practices and policies in that. Some things that it will not do is correct raw data inaccuracies or perform any type of field validation to corroborate some of the numbers that we're seeing in the water audit. All right, just a quick check on time. Alex, maybe let me go to you first to see if you have any questions on data reliability, and then we'll address those, and then I'll pass it back over to Steve to talk about what is next with talking about non-revenue water data reliability in Romania.
Okay, well, I have already a question from our group, and I'll try to translate it as best as possible. How can you do an audit for a system that has no verified data, where flow meters, big flow meters cannot be verified, and the domestic meters are very old? Probably it's not a singular case.
Yep.
Yeah.
So I'll start, Drew, if I can. So again, a little bit of a similar question that came earlier, and you have to, it can never be excused not to do it. That's the first thing. And we say this a lot of, well, if I get my meters fixed, then we'll do it. And what happens is you have years and years to get things fundamentally improved upon. You have to make your best estimates based on what you're doing, what you can measure, what you can do. Maybe it's tapping a line and doing a pitot test for a main service line that's coming in, that you can at least get that done. Maybe it's you're doing a drop tank test with a reservoir that's right there, and do a volumetric test, but some way that you're improving and informing those estimates. So I mean, it could be that the supply weir, if you will, that's coming from a reservoir that you're looking at it and making estimates. There's engineering analysis that needs to be done on that front end to get your best estimates. But the reliability by doing that, as Drew said, is extremely low. But extremely low is better than nothing. You're getting started. Conversely, on the consumption, it may be looking at population, number of building flats, historical, some sub-metering that's done that you then are extrapolating that data. So that's what I would say, is that many times it becomes the excuse. We can't do it until we get this done, and the problem is we never get started, and we can't show that our baseline water balance may have had this level and it had a wide sensitivity analysis of the accuracy, to where as you're making improvements over time, you're improving that accuracy and improving the results that come from it. So I think this is a similar question that was asked earlier, Alex, and we say you've got to get started. You got to get started trying it, best engineering estimates you can to inform it, and improve it with means of physical measurement. Does that help?
Well, certainly. I propose to move on and and see if we have any other questions after the web.
Sure. So very quickly, we'll do a workshop preview. If you can hit the next slide, Drew. So we're excited to be coming to Bucharest, and this will be the 7th of October. Drew has on the right side the free water audit software, the worksheet that will be translated, but it's in SI units that we can work through. We see that the utilities will be working with the data, with the spreadsheet, being able to work on the water balance. I also think, because of the questions that have been asked, we're going to have some discussion about estimation practices. How do we go about systems that don't have meters, and maybe show some examples and work through those together. But we anticipate that it's going to be interactive with the utilities, bringing your information, your case study information for dialogue and discussion, framed around these key concepts. The audit exercise, going through and inputting into the spreadsheet, discussion on data reliability, the validation piece, and then thinking about what may be coming which is next slide, Drew, of having some conversation about maybe a long-reaching, go ahead and go next slide, Drew. In the United States, we've been able to set up technical assistance and training programs where it's utilities over a 1, 2, 3 year period are making improvements of auditing and going through the validation step, but they're doing it in a way that they're sharing and learning together. This could be something in Romania that might be a broader thing long term, maybe for the association to be an active part in. So those are just some ideas that we wanted to sort of plant out there and close with. But I hope that all of you will plan on attending and bringing not just yourself, but bring others in the water utility from distribution, billing, metering, supply, customer service, where the more we have the broader utility understanding what information is needed, the more buy-in you get. So I think that's an important piece to think about as well. So Alex, we'll bucket back to you. I know we're right at the top of the hour, but we started a couple minutes late, but maybe for some more questions or comments that you may have regarding the workshop.
Okay, so I will ask if someone from the audience have any questions. Deci dacă sunt întrebări, le puteți intra direct să-l puneți întrebările sau le puteți scrie în chat. Nu sunt, so there are not too many. However, I would like to make some maybe some closing remarks in Romanian about this and further information about the workshop. Bun, deci după cum ați înțeles, va exista un atelier de lucru, un workshop de 7 octombrie la Universitatea Tehnică București. Vă așteptăm un număr cât mai mare. Și unul dintre subiectele pe care și Steve le-a exprimat este faptul că dorim ca dumneavoastră să veniți cu niște cazuri reale. Adică dacă aveți întrebări sau neclarități despre o anumită rețea sau despre un anumit sistem, să veniți să le puneți acolo, să încercăm împreună să le dăm de cap ca parte a workshop-ului. Cel mai bine ar fi totuși ca, în cazul în care există o astfel de cerință, să ne le trimiteți cumva înainte ca să putem face o reevaluare. Nu știu dacă am menționat sau nu, dar sunt toate șansele și așa ne vom ține de promisiune că acest workshop va fi gratuit, nu va fi nicio taxă de participare, în cazul în care asta ar fi fost una dintre întrebări. Și va fi doar de o zi. Ați mai observat probabil că pe parcursul acestui webinar nu au mai existat traduceri. În trecut traduceam eu și nu sunt cel mai priceput la traduceri. Am preferat ca de data asta să lăsăm, fiind vorba de limba engleză, să lăsăm webinarul așa. Există în momentul de față foarte multe unelte de inteligență artificială care ne pot ajuta să traducem destul de corect în timp real. So, Steve, I just made some closing remarks, urging people to come to the workshop and also to bring some questions about the system that they have. They could send it before that to you, okay, just to have a preview, okay. One question that also popped up right now in the chat, okay, how do you estimate the volume lost through theft?
Yes, I saw it. Thank you, Alan, for the question. So very quickly, in the free water software, this is a challenge in the US as well. You don't know what those numbers are. If you knew, you would stop it, of course. So there are some estimates based on system knowledge, number of systems at 0.25% of your billed metered consumption, but that can be very low. And so it may be that needs to be elevated up, but there are some defaults or some starting points that we can talk about. It may be that in the discussion when we're in the workshop that number needs to be a bit higher based on what you observe and what you see. But it's surveillance. It's actually making the various utility directors know, or utility personnel know. It's letting the police know what theft looks like. And so you're improving surveillance. You're also looking at historical information and seeing is that is spiking. So, and you're making estimates from that, but indeed it is an estimate. And so, but you're trying to get it more frequent, such as monthly, that you're looking at it instead of, well, how much do you think we lost through theft? So that is enhancing your points at which you are starting to make those estimates, which should improve the estimates. Alan, does that help answer your question? We'll talk more about it when we're together, but wanted to throw that response out.
Thank you very much.
Good question. Great question. Okay. Alex, anything else?
I just want to thank anyone and it's a very good turnout for our webinar. It will be on our YouTube channel. Just want to make, before we say goodbye, just some closing remarks in Romanian. Bun, mesajul care ar trebui luat este că în momentul în care ai, chiar dacă calculezi balanța APEI și asta, întotdeauna informațiile ar trebui însoțite de toate cifrele de o marjă de eroare și de un anumit grad de fiabilitate a datelor sau grad de încredere, pentru că asta ajută mai departe la luarea deciziei. Da? Este în momentul în care ai date de proastă calitate sau inexistente, este din ce în ce mai greu. Dar trebuie să încep de undeva. Este mult mai complicat decât pare la prima vedere. Realizarea unei balanțe de apă în momentul în care datele nu prea există un istoric și nu ai de ce să bazezi, este mult mai complicat decât pare la prima vedere. Deci odată realizată prima încercare, este absolut necesar ca în viitor apropiat, măcar o dată pe an, ca acuratețea acestor date să fie îmbunătățită prin diverse măsuri. Da? Nu poți merge la nesfârșit doar cu estimări. Trebuie la un moment dat să ai măsurători. So Steve, just one final question that I have. So you said about all the concept that you presented, all this methodology, okay, it's tailored more for the water utilities, or it's tailored more for the, let's say, consultants? Or how do you see the interaction, let's say, between two groups or other groups like regulators, for example? Okay, how do you see this regulation?
It's a great question. So from a technical assistance and training and what the workshop will be doing, it's going to be very hands-on. It's the utilities learning the methodology, bringing their case studies, interacting. It would be ideal if we have regulators there to understand the importance and also the progression that utilities get improvement, and that they can look at funding or improvements in reporting. Because in many cases, it certainly is in the States, and I think it is in Romania, where it's actually still on a percentage basis. And so how we can start to look at better metrics for performance. So it'd be ideal if they are there. From consultants, we have a lot of consultants that attend training, and I think that's fantastic if you work with consultants. I didn't think it was as consultant heavy in Romania of interacting. It's more to get the utilities to learn the process and to implement these best practices on their own. That's why I said bringing billing, supply, distribution, metering, etc. to this, so you're increasing the body of knowledge to where the utilities learn this for themselves. But consultants are certainly welcome. Is that what you're asking, Alex?
Yes, more or less. Yes. No, you responded perfectly to my question.
Okay.
Thank you very much.
Okay. Very good. Well, I want to see everybody. I'm excited to come back to Romania and to introduce Drew to Romania and to see all of you. But do bring others. And congratulations on over 20 on the webcast today. That was outstanding, Alex.
Well, it's not my It's everyone else's support that bring us here. So
Yep.
we thank you very much for your time, for your presentation, and we welcome everyone and for possible question. And we also will welcome you to our workshop, and we hope that we can continue further with all this approach, because from what I saw, the states in Romania, at least in this field, are not that different.
That's right.
There is a very common history here, at least in this field. So I think
right.
it's something that we can both learn from each other. Okay.
Absolutely.
So
Perfect.
thank you very much. If you have any closing words or arguments, please.
Mulțumesc and la revedere.
One question, serious.
Yes, Alan.
Trump or Kamala?
We're going, no. By the way, we are going to delete the answer from YouTube channel, okay? We are going to post it, depending on the results, we are going to post it after the election, just so you can...
Oh, I see.
Okay,
yes.
So...
How do I understand Alan's question? Who knows? Okay. We have a term here, it's cluster, and then you fill in the word. That's what we're in over here. So the world's watching and we know. We don't know.
Thank you.
Okay.
Then, yeah. All right.
Bye-bye, everyone. Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Revedere.
Bye bye.